Hello friends, welcome you all to the lecture series of the DBMS. The subject code is PCS 50 from the AKT University. I welcome you all. Myself Ritin Behel, Assistant Professor from ABES Engineering College, Ghaziabad. Today we are going to discuss about a very important topic, that is the transition processing concept. In the previous lecture, we have seen that conflict serializable schedules, reserializable schedules, recoverability, what are irrecoverable schedules. Now today we are going to discuss about some important concept of recoverable schedules, what are recoverable, what are not recoverable schedules, cascading schedules, cascadeless schedules, and the strict schedules. Now, these kind of the schedules are there. After this thing, we have seen that when we have given to the point is whether we are able to get a serial schedule or not. Now, how do we get it? By the two techniques. Again, I am repeating the important concept: the view serializable method and the conflict serializable. Now, once we have seen that in these two conditions, we can find a serial order or not. But in case if it fails in both the condition, our transaction schedules can be recoverable or in recoverable situation, or what we need to do to make sure that the overall goal of concurrency is maintained. So today we are going to discuss about these important points. Let us go further and discuss recoverability. So what do you mean by recoverability? Something something goes bad and we have a method to recover it back. It can be a kind of a data and something. When we talk about DBMS, mostly it's a data. So what is there is important to design a recoverable schedules. To achieve this, we need to place restrictions on the type of the schedules permitted in the system. So we need to take some kind of the restrictions in order to proceed with this thing. The type of schedule accepted from the viewpoint of the recovery of the transition failures are recoverable schedules, cascadeless schedules, and the strict schedules. So which we can further see in that. So let us discuss each one in a detailed part. What are recoverable schedules? A recoverable schedule is one where for each pair of transaction Ti and Tj such that reads the data item previously written by Ti and commit operation of Ti appears before the operation of the Tj. So what it's saying is we need to place commit. Where we need to place a commit, for example, we have a transaction 1 here and transaction 2 here. We have read A. So we have seen that if we read A here, write A here, and slowly, but it fails. So we have to go it back. And there is some kind of information that was not correctly there. And these kind of schedules are irrecoverable. So what they are putting is now put a commit, and then only we can perform the another operation of the different transactions. Okay. So read a data item for each pair of transaction Ti and Tj such that Tj reads. So what Tj reads? So this is T2, Tj reads after the T1 appears before the commit operation of this thing. Now let us see an example. Read a value of Q. Now Q is 20 here. Now Q is Q plus 30, so Q becomes 20 plus 30. That is Q in the buffer part is 50. Remember that this is buffer or a cache memory. We have not updated in the database. Write Q. Okay, we have updated in the buffer part. Now it commits. Now this value has been changed and updated to the database. Now the value of Q in the database is 50, whereas earlier it was 20. Okay, see, it's there. So now it reads Q. Now what the B, T2 reads Q. It's not reads 20. It reads the value of 50. Now Q is 25, 35. So it becomes 85. Okay, it's become 85. So what it says is write Q. Q updates the value of 85. It's just 25 something. So it is 25. 75 updated in the system. It fails. Due to any reason the faculty fails, no impact on the T2. Doesn't make any difference because we have already committed here. And this value has been updated. This value has been updated in which part? The database part. So these kind of schedules are correct, which is correct, and they are recoverable. Okay. So this would be 25 and this would be the 75 values. Okay. So what we need to find is what are the recoverable schedule. We need to check the order of the commit. So if any data item is reading out, it need to be checked. Previously transaction has committed that data item. Okay. Cascading one by one, depending upon, it's like a ladder and something. So let's see the example. The same thing written in the theoretical part also. We have a 3 transactions, T5, T6, T7, and all are doing simultaneously. Now T5 read a value of A, something like this, read a value of B and write a value of A. Now T6 also read a value, and depending upon this value, read karenge and write karenge, and after that read it. Now in future what happens? T5 fails here. So it is rollback here. So this also depending, this also rollbacks, and this also saying, and this rollback. So with the failure of one transaction, the other two transactions are affected and they are also rolled back. And this kind of schedule are called as a, and they are called as a cascading rollback. Now let us read out the same data. Transaction T5 writes a value of A, that is read by transaction T6. Transaction T6 write a value of something of A, and that is read by the value of T7. Now suppose that transaction fails somehow in T5, T6 must be rolled back. Since T7 is dependent upon T6, T7 is rolled back. This phenomenon is a single transaction failure. So this is single transaction failure. With a single transaction leads to a series of transaction rollback, and it is called as cascading rollback. So again, for cascading rollback, we need to remove it so that in future it doesn't happen. And for that, we have a cascadeless schedules. And let's see how do it work with a cascadeless schedule. Cascading rollback is undesirable since it leads to the undoing of the significant amount of the work, because the T5 fails, but if it's affecting T6 also and T7 also. It's desirable to restrict the schedule to those who where cascading rollbacks cannot occur. You need to do that, and such kind of schedules are called cascade-less schedules, and we see that in the next slide. What are the cascades? Therefore, we must design cascade-less schedules. Okay, let's see that cascade-less schedule is a cascade schedule is one where for each pair of transaction Ti and Tj, for each pair of transaction Tn such that Tg reads the data item previously written by Ti. What is saying is read the data item previously written by there. The commit operation of Ti appears before the read operation of the Tj. It was written in the previous one, the recoverable read commit was there, and now it's in cascading. We need to put a commit before the read operation. As shown in the figure below, it is easy to verify the cascade will also recoverable. Now see that read B, write A, commit. Now only thing that a Tj can read the value when T1 has commit. Write B and commit and so on. So this is a cascade schedule. Even if it is fail here, it will not be affecting here. Even if it is fail here, it is not going to affect here. And similarly like this. Read A, write A, write A. Now this is possible or not. We have to see that. Cascade-less only guarantee you of commit followed by read operation. What do we do with the write operation? Still problem exists. To recover this problem, we say that we have another kind of a schedule, that is strict schedule, and this one. Now see this thing, if in a schedule a transaction neither allowed to read or nor write it until the last transaction that has been written is committed. For example, T1 is here, T2 is here, read, write, read A, not allowed. Write A, not allowed. Allowed when? When only it put a commit, then only read or write A is allowed. This example is known as the write A, commit or rollback, read and write B, then it is allowed. 6 schedules are stricter than cascaded schedules. Every schedule has a cascaded schedule, and vice versa is not true. So if you see then strict, cascadeless, and the recoverable. So what exactly we want to achieve in this transaction part is our schedule will be strict schedule. Because if a schedule is strict, it would be cascadeless also, and it could be recoverable also. So I hope you have learned from today's lecture. Strict schedules, cascadeless schedule, and recoverable schedules. These are the reference we have taken it. Thank you.